All right, we're gonna go ahead and get started. Welcome to the CPTC meeting. Tuesdays at 6:30 p.m. as always. And today we're gonna be continuing with the OWASP Top 10 Part 3. How's it going, Nathan?
I'm all right. How are you?
Pretty good, pretty good. Yeah, I think at this point, because people are so busy, it makes more sense to just sort of record these and then post it on the YouTube so people can watch them later. But I'm glad you're here with me.
Okay.
So we're gonna continue with OWASP Top 10 Part 3. So again, things to know, any topics you would like to learn. We're towards the end of the semester now, so this will be good, useful for, I guess, in the fall, this coming fall, or maybe even the summer, for whoever is going to be the next red team chair. Take these on. Again, people who haven't joined the UFCPTC Slack and Discord, those are the links there. And then again, we post all of these lectures on the UFCT YouTube channel. And then if you need a Kali VM, if you want to practice on your own and stuff like that, you can, and you don't know how to set one up yourself, you can send me a DM and I'll set, and I can help you get set up with USB for client. And also make sure you have an account with TryHackMe and Hack the Box. Today we're going to be using TryHackMe. So that'll be useful to have today. So what we're going to do today, again, is going to continue learning with OWASP Top 10. This is going to be, I think, the second to last OWASP Top 10 we do, because after this one, there's like, I think 2 or 3 more that we have to do, and then we'll have gone through all the OWASP Top 10. So I'll probably do the OWASP Top 10 either in the next meeting or the one after, depending on how many weeks we have left in the semester. I'm not actually sure. And then they're continuing with that same TryHackMe room on the OWASP Top 10. So you can see here, just to recap again for people who haven't seen the other ones, the OWASP Top 10 represents the top 10 most critical and common security vulnerabilities that exist in web applications. It gets updated every few years to represent the newest data on the most common vulnerabilities. Hasn't been updated since about 2017, so I guess for the past 4 years or so, these vulnerabilities have stayed pretty consistent as the top 10. The ones that are crossed out are the ones that we have already done. So we've gone over injection, broken authentication, XSS, insecurity serialization, and using components of known vulns. That'll be in the last part 1 and part 2, which you can see on the YouTube channel. And the ones that are starred and the ones we're doing today, that's going to be sensitive data exposure and XML external entities, or XXE. And then the last one, the next meeting, we'll go over the last 3, which is going to be broken access control, security misconfiguration, and insufficient logging monitoring. So let's get into it. So sensitive data exposure. So these vulnerabilities are kind of vague, but they essentially apply to any vulnerability that involves the improper or missing protection of sensitive data. So this sensitive data can be anything from usernames and passwords to maybe credit cards, social security numbers, anything that might be sensitive that like the owner of said website would obviously not want to have exposed to the public internet. And then because it's really vague, so the data that, like, how it can be compromised can be compromised like in a many number of ways. Weak encryption is one, like it says man in the middle, bad file permissions, etc. There's a whole bunch of ways that the data can be exposed, which is why this vulnerability is so pertinent and why it's in the top 10. But it's also it's kind of vague. It's not like very specific like it is with like XSS, for example, which is a very specific vulnerability with JavaScript. This is more of a general sort of vulnerability with the sensitive data that your website has is exposed somehow in some way. So we're gonna go ahead and actually just hop onto the TryHackMe here, take a look at it. So I'm gonna go to TryHackMe. Wait for this to load. Go ahead and log in. Internet is slow today. All right, so we'll start off here in the dashboard, and then once it loads, actually, let's go ahead and click on Learn, and then go to All Labs, then just do a search for OWASP Top 10, and that's what we want. I'll click on that guy. All right, and as you can see, we've completed a lot of this so far. So we're almost there in terms of the lab. So let's go ahead and go to the sensitive data exposure part, which is right here, task number 8. So I'll read the introduction here. When a web app accidentally divulges sensitive data, we refer to it as sensitive data exposure. This is often data directly linked to a customer, like I was saying before, names, date of birth, financial information, etc. But it can also be more technical information such as username and passwords. At more complex levels, it often involves techniques such as man-in-the-middle attacks, whereby the attacker would force user connections through a device which they control, then take advantage of weak encryption on any transmitted data to gain access to the intercepted information. So that example man-in-the-middle would be like, if you were to somehow able to get between like someone's computer and like you have to act as their router, and they were accessing a site that didn't use encryption, like was just sending everything to plain text, then you can basically see all the data that they were sending. So you can basically, if they were logging into things, you could see what their login was, all that kind of stuff. So that's an example of like a man-in-the-middle attack. So yeah, basically everything I recapped before. The web application in this box contains one such vulnerability. Deploy the machine, then read the supporting material. All right, cool. So we'll go ahead and start up the machine here. And then I'm also going to go ahead and start up my OVPN file. For those who don't know how to access that, you want to go to tryhackme.com/access. And then it's going to be this guy here. Choose the region that's closest to you. For me, it's East Regular 1. And then you download configuration file, which is going to be a .ovpn file. Then you want to go to your terminal. And then wherever you have your that file, wherever it is, you want to go to it. Mine's in here. You want to do sudo openvpn, and then the name of the file. And then once you see initialization sequence completed, you know that you're connected and you're good to go. And then leave this terminal open for the remainder of the lab. So any other work you want to do is open up a new tab for that. But yeah, let's go back to the box here. All right, so cool. We have an IP. Let's move on to the next section. I'll give everyone a minute just to get their thing started and stuff. Okay, so we'll go on to the next part. The most common way to store a large amount of data in a format that is easily accessible. Accessible is in a database. And then for those who don't know, usually the most common database language is SQL, or structured query language. There are alternate formats such as NoSQL. In a production environment, it is common to see database set up on dedicated servers, running database services as MySQL or MariaDB. However, databases can also be stored as files. These are called flat file databases, and they are stored as a single file on the computer. This is much easier than setting up a full database server, and so it could potentially be seen in smaller web applications. So accessing a database server is out of the scope of today's task. Let's focus on, flat file databases. Okay, yeah, so pretty standard what they're saying. It's essentially if you want to like run an entire MySQL server on your, or have a dedicated server just for like MySQL running on it, you just have a flat file database, which is just a single database file that can just be read from and written to by the web server, instead of having to have a whole database server running. As mentioned previously, flat file databases are stored as a file on the disk of a computer. Usually this would not be a problem for web app, but what happens if the database is stored underneath the root directory of the website? For example, one of the files that a user connecting to the website is able to access. Well, we can download it and query it on our own machine with full access to everything on the database, which is sensitive data exposure. So that's a hint for the challenge. Okay. The most common and simplest format of a flat file database is an SQLite database. These can be interacted with in most programming languages and have a dedicated client for querying them on the command line. This client is called SQLite 3 and is installed by default on Kali. So if you guys have taken like a databases class, then you'll definitely be familiar with SQLite 3, because I think UF, that's the language or the file format you guys deal with. So let's suppose we have successfully managed to download a database. They have a flat file database called example.db here. They ran file on it to determine what type of file it is. It told it it's an SQLite 3 database file. And then you can access it by running SQLite 3 and then the name of the file, it's example.db, like they do here. And then they get dropped into a little SQLite terminal where they can then query the stuff from the database. So you can see here they do .tables to list the tables that are inside of the database, which is a table called customers. Then what they do is they first see what information or what columns are inside of the table, and what's using this command here, pragma table info customers, which just returns info about the tables, specifically the different columns that are in the table. So we have a cust ID, which I guess stands for customer ID, customer name, credit card, password. And then if you do select all from customers, you're going to see here we have, just like saying the customer ID right here, we have got the customer name, we have the credit card, we have the password. So this is definitely, if you were to find something like this out in like the real world on a actual web server, that's definitely sensitive data exposure vulnerability. We can see from the table information that there are 4 columns, like I was saying. Cool. And the next task, we'll look at trying to crack the hash. Yeah, you'll notice here that these aren't like just normal plain text passwords, because no one in like their reasonable mind would have this as like their actual password. These passwords have been hashed to be stored, which is good in most cases. You want to make sure you're not storing plain text of your passwords. But the issue with this is that we can then potentially crack that hash if it's a very weak password. So let's move on to the next part here. So in the previous task, we saw how to query an SQL database. We found password hashes. So we'll briefly cover how to crack these. Okay, so there's a lot of online tools. This is basically what it's saying. There's a lot of online tools you can use to crack hashes. However, there are kind of 2 ways that you can crack a hash, and whichever way you choose depends entirely on the kind of hash it is. So there's one that's called a rainbow tables attack, which is one that you're seeing here by using an online cracker. And what that means is that the hash is unsalted, right? So it's just been run through like one of the hashing algorithms like MD5 or SHA-256, and it has not been salted in any sort of way. It hasn't been changed. That's just exactly how it is. If you were to hash that password with the same algorithm 100 times, it will come up with the same exact hash. And so what that means is that you can give that hash to one of these websites here, and it's going to check against its massive database of hashes and passwords to see if any of it matches. And then if it does, it'll give you back the plain text version of that password. And that's known as a rainbow tables attack. So that massive database that they have is known technically as a rainbow table, where it's just a massive database of basically passwords and their related hash. And then if you give it a hash, it'll look for that hash in this table. If it finds it, it'll match it up with its password and then give it to you. So that's the first way that you can crack a hash. And it's like it's the easiest way, essentially. It's the quickest. You just throw it into one of these and it'll spit it out. The harder way is that if the hash has been salted, meaning that the hash has been basically, you've added a few random characters at the beginning of the password, essentially, to give it a sort of randomness to it. So that way that each time you hash the password, like you've hashed it 100 times, you're going to get, and it has a different salt, it's going to get hashed, 100 different times. So you're not going to be able to run rainbow tables on it because it's basically an entirely unique hash. And so in order to crack that kind, you need to actually run like Hashcat or John the Ripper on it. And what those are basically where like it'll basically try to brute force the password. So you can provide it like a word list of like a dictionary to try to crack it against. One popular one is rockyou.txt. Probably the most popular one is rockyou.txt. Another way, that's called a dictionary attack, where you just try a list of most common passwords. Another way is like brute forcing it by just like literally trying each character one by one. Like you start like 0, 1, 2, 3, 4, 5, 6, 7, A, B, C, D, E, and then you keep going until basically hopefully you've cracked a hash. But that takes obviously both those, like using either dictionary attack or brute force attack can take like a long time. Specifically, brute forcing can take like, theoretically, there's like a lot of like theoretical stuff to that. Like theoretically, it take like, if it's a really strong password, like, years and years to actually crack it. So preferably, well, from a security perspective, you want to have good security. You want to make sure all your hashes are salted, because that means it can't be cracked against a rainbow table attack. But if you're a hacker, you're kind of praying that it can be thrown into a rainbow table, because then that means it's not been salted, and then you can actually, you know, makes your life a lot easier. Because most of the time you're not gonna be able to reasonably crack it using some like hash counter on the Ripper, again, unless it's like a super weak password. And that's basically what this is sort of going over, is how a popular one is called CrackStation, is an online thing. We can go look at it right now, where once it loads, yeah, you essentially give it a password hash, and then it'll just look for it in its database. So it's technically not cracking the hash, it's just sort of just checking it in its database if it exists, and then if it does, it'll just spit out the related plain text password. So it's definitely useful. But yeah, this is an example of just a rainbow tables attack. So, and this is an example of they're using it here. You can see they put in this hash here, they click crack hashes, and then it found it. This is the hash that you gave it, and then it tells you the hash type, which is MD5. That was the algorithm that was used to hash it, and then it gives you the result, which this is just a hash for password. So cool. Let's go to the next section. So it's time to put learn to practice. Have a look around the web app. The developer has left themselves a note indicating, I'm trying to just hide the answers here. The developer has left themselves a note indicating that there's a sense of data in a specific directory. What is the name of the mentioned directory? So let's go ahead and go to the IP here they give us. Copy that. Let's go here. Okay, so we have here a little pretty basic website here. It says, welcome to Sense and Sensitivity. You've reached the future world #1 in all things therapeutic. We're a startup organization based in New Zealand. Our location near the stunning Lake Taipo lends itself perfectly to right. Okay, boring stuff. For time being, we're only doing beta testing the program. Context is here. Okay, that's just a mailing address. So let's take a look around. We just have this. Let's go to, there's a login page here, which is nice. Okay. Can't really do much there. Let's see if there's a robots.txt. There isn't. Okay. Let's look at the source code of this web page. Maybe the developer left some comments in here. Okay, so they didn't leave any comments from what it looks like. Not seeing any comments. Yeah. But what we do have here is a few directories. They have assets, images, like typeout, PNG, also the CSS stuff. So let's go ahead and look at that. It's going to pull up this beautiful image here. But let's go to see if we can actually list everything inside of images. Oh, this is the source code. Let me go to the actual /assets/images. Okay, it looks like we can. So this is a potential vulnerability in itself if the stuff in here is sensitive. Usually you don't want to allow any sort of outside user to be able to list all the files in a directory like this. But since we can, let's see what we can get here. So let's go up one parent directory to /assets. And we got CSS, fonts, images, JS, PHP, and well, you know, we have a webapp.db, and that looks like a flat file database to me. Just out of curiosity, I want to check out the PHP folder. Check login. I mean, this could be also useful stuff for. This could also be useful if, like, for finding vulnerabilities inside their PHP code. If they have like, you know, maybe they're vulnerable to SQL injection, then check login and stuff like that. But today we're focusing on the webapp.db. So let's go ahead and download that. Go ahead and save that file. I'm going to move it over to this directory here, just so I can work within this way. So, or let me go to OWASP. Okay, so cool. We found something interesting. So yeah, what is the name of the mentioned directory? We found it in /assets. Navigate to the directory you found. Question: what file stands out as like being likely to contain sensitive data? And that's webapp.db, which we just found. Using the supporting material to access the sensitive data, what is the password hash of the admin user? So now we're going to do what they were saying before by using the SQLite command to access it. So let's SQLite mode. Oh wait, SQLite 3. There we go. So now let's do what they're saying. Let's list the tables inside of this directory. We've got a table called sessions, table type users. Let's see what columns these guys have. So let's do pragma. I think it was a table underscore info. Let's check sessions first. Okay, so the sessions table has a column called session ID, user ID, and expiry. That's probably, actually, let's take a look. Let's do select all from sessions. Oh, okay, it's empty. Usually, this sounds like something that would be like for cookies and stuff. When someone logs in, the cookie would get stored here, which actually could be very useful for us, because if, like, let's say the admin is logged in there, that means their session cookie is going to be stored here. And if we can steal that, we can log in as the admin. Of course, as you'll see in a second, we don't really need that because we're about to get his entire his username and his password. But in the case that, let's say, his password was not crackable, we could just wait for him to log in, steal his session cookie, and then log in with that session cookie. And then we'd essentially just be able to log in as him because we just have a session cookie. But here, let's do pragma tables again on table info on the users table. Okay, so we have a user ID, a username, a password, and then we have an admin column. So let's do select all from users. Okay, so we've got this is the ID, the user ID. This is the username. This is the password, and then I'm guessing this is the admin being a Boolean value for whether or not this user is an admin or not. One admin is obviously an admin, says one. Bob is apparently an admin, and Alice is not an admin. Cool. So what is the password hash of the admin user? Well, we've got it. It's right here. Let's copy that over, and then what you see, we have it right here. So we found the admin hash of the user. So I'm guessing next they want us to crack it. Let's see, crack the hash. So we're going to do what they said. We're going to do a rainbow table attack. We're going to copy the hash, go to crack station, throw it in there, make sure we're not a robot, crack the hash, and then you see it found it, and this is the password. So what this means is that essentially crack station, the website, has a massive database of hashes and the related plain text, and that means in its database it has this hash in it, and it has this related plain text inside of it. So go ahead and copy that. So this is the admin's plain text password. We'll go there and we'll throw it in, and there you go, it is. So log in as the admin, and let's get the flag. So let's go ahead and complete this guy by going back to the main site here. Go to login, go to admin as the username, paste in that password, and boom, we got the flag right here. We have login as admin. And you can see we have some more. We can add a new user, delete a user, all this fun stuff. I'm curious, since now that we're logged in, if it's going to create a session inside of the that session table. So I want to go back to the, what was the IP again? Let me copy that. I want to go back here, and I want to re-download the SQLite file. Go ahead and save that. Do .quit. I want to see if it added anything to it. So let's select all from sessions. Okay, it didn't. So I think usually it would, but this site isn't exactly super advanced, so it didn't. But in the cases that it would, like in a normal case where it would add the this admin user session cookie to this, because we just logged in as it. Let's say we couldn't crack his password, like it didn't exist in any of the rainbow tables, and it was like super complicated, so we couldn't like crack it with Hashcat or John the Ripper. We can literally just wait for him to log in, and then his session will show up on here. We can copy that, put it in as our cookie, and then we can just log in, and it'll just automatically log us in, and then we basically have admin. And then from there we can, like, change the password and all that stuff. But yeah, we got the flag, and I think that just about completed this challenge. So yeah, trying to think if there's anything else I should cover here. just for people who don't know, to quit SQLite, that took me a while to figure out, is .quit. We'll quit it. You have to put like dot in front of it. That's kind of annoying, but yeah. Yeah, okay, cool. So let's go ahead and go to the next part, the next vulnerability, which is going to be XXE. So XML external entities, also known as XXE for short. It's a vulnerability that involves XML interpreters that are not configured properly and then can lead to misuse. And this misuse can include getting like stealing sensitive files, causing denial of service attacks, and even potentially gaining remote code execution on the victim machine or the victim web server that the interpreter is running on. From my experience, and also from what I've heard from a lot of other people, XC vulnerabilities aren't actually as common these days, but I suppose they are common enough to still have a spot in the OWASP top 10, or at the very least, they're still severe enough where they have a spot in the OWASP top 10. But from my experience, most XML interpreters are pretty rock solid these days, where you have to find like a really old website if you really want to find an XSE vulnerability. But nevertheless, it has a spot in the OWASP top 10, so we're going to go ahead and go over it. So let's go ahead and hop into the Try Hack Me room. So an XML external entity attack is a vulnerability that abuses features of XML's parsers and data. It can allow an attacker to interact with any backend or external system the application itself can access, and can read the file in the system, then cause denial of service attacks, or even perform server-side request forgery, inducing the web application to make requests to other applications. So yeah, something else I didn't mention was that another potential harm that actually you can do is that it can cause something called server-side request forgery. And what that means is that you're basically forcing a web server to make a request on your behalf. So it doesn't look like it's coming from you. They're essentially acting as a proxy, where like, let's say you can force a web server to access internal network data that only that server can access, but then return it to you for you. So like we usually would not be able to access that internal data. You ask the server to, and it will do it for you. And that's called server-side request forgery. XC may be able to enable port scanning and lead to remote code execution. So there are two types of XC attacks, in-band and out-of-band. An in-band XC attack is one in which the attacker can receive an immediate response to the XXE payload. Out-of-band, or also called blind XXE, is when there is no immediate response from the web application, and the attacker has to reflect the output of their XXE payload to some other file on their own server. So that would be essentially something like where it wouldn't, the XML parser isn't going to just like display the output to you directly on that web page, maybe because like the web server isn't designed for the parser to do that in any way. Like for example, if you're like, it has a website where it lets you upload XML documents. Most of the time, they're not going to like have a feature in which they display it back to you. It's just going to be like, thank you for uploading. That's it. In those cases, you're not going to be able to see the output of whatever command you're executing. So you have to send that output to like your own external web server. So if you're able to execute commands through their XML parser, if you type in like who am I or ls, it's not going to show just straight up on their web server. You have to type like, okay, run ls and then send the output of that command to my web server. So that's what they mean by out of band and in band, or in band or blind XXE. So let's go to the next spot and get some water. So what is XML? XML stands for Extensible Markup Language, and it defines a set of rules for encoding documents in a format that is both human readable and machine readable. I think most people here probably know what XML is. They probably used like Excel before, that kind of stuff. That's used for storing and transporting data. Why do we use XML? It's platform independent and program language independent, thus can be used on any system and supports the technology change when that happens. The data stored and transported using XML can be changed at any point in time without affecting the data presentation. XML allows validation using DDT and schemas. This validation ensures that XML documents is free from any syntax errors. So something that's like, we're not going to cover in this one because it's a little more advanced than XCCs, but you can actually use malicious DDT files to actually help implement your XSE attack. where your DDT will actually have the malicious code in it, and then that'll be used by the XML parser, and then it gets executed that way as well. So like, for example, let's say like, I'll just go briefly on this because it's a bit like a little too like low level, but let's say you're at the XML parser you're trying to like get a vulnerability on isn't letting you execute like certain commands, right? Like it's like basically blocking you from like, if you try to, read files or execute like a shell level command, it's just blocking it, right? It has like, it's good in that sense where it's like, it's secure enough where it's not letting you do those things. But what it does do is it lets you download a DDT schema and use that. Now what you can do is that create your own DDT schema and put all of your, execute shell commands, read files on that thing, on that DDT file. And then you have in the XML parser, you tell it to download that DDT and execute it, and then it'll do it, and it'll basically bypass any restrictions that you had before. So yeah, that's sort of just a small insight into the DDT vulnerabilities. Another, I guess, XML simplifies data sharing between various systems because of its platform independent nature. XML data doesn't require any conversion when transferred between different systems. So those are sort of the benefits of XML. This is the syntax for it. So every XML document mostly starts with what is known as a prologue, which is just this. Again, I'm sure a lot of you guys have seen this before. XML version 1.0 encoding UTF-8. Above the line is called the above line is called XML prologue, and it specifies the XML version and the encoding used in the XML document. This line is not compulsory to use, but it is considered good practice to put that line in all your XML documents. So I actually didn't know that. I thought it was required, but I guess it's not. Every XML document must contain a root element. For example, we have mail, falcon, feast, about, XC, teach about. And in both examples, the mail, this guy, the mail tag is the root element. And to, from, subject, and text are the children elements. Excuse me. If the XML document doesn't have any root element, then it would be considered wrong or invalid XML. Another thing to remember is that XML is a case-sensitive language. If a tag starts with 2, then it has to end with /2, not with a capital T. Like HTML, we can use attributes in XML too. The syntax for having attributes is also very similar to HTML. Okay, that's pretty straightforward stuff. So full form XML is called extensible markup language. It told us right there. Is it compulsory to have XML program and XML documents? It is not. It's not required. Can we validate XML documents against a schema? We can. Schema such as, like I was saying before, DDT or schema. How can we specify XML version and encoding an XML document? And that's using the XML prologue, like you see right here, the version here, and the encoding, which is UTF-8. I think, like, if you don't include the prologue, I think these are the defaults here, 1.0 UTF-8. So if you want to change those, you have to include a prologue then, I'd imagine. So let's move on to the next part. So before we move on, starting with XC, we'll have to understand what a DDT is in XML. DDT stands for document type definition. A DDT defines the structure and the legal elements and attributes of an XML document. Let's try to understand this with the help of an example. So say we have a file named note.ddt with the following content. It's doc type note, element note, to from head body, element 2. This is like stuff that like I don't even personally like understand because I can't really read this. I don't know if it's super human readable, but that's okay. You don't really have to know it. So now we can use the DDT to validate the information of some XML document and make sure the XML file conforms to the rules of that DDT. Below is a given XML document that uses note.ddt. So, okay, yeah. So DDT is basically just a way to like check, like make sure that it matches, that whatever is here or whatever is using the note.ddt is following this format that they specified here. So let's understand how it's validating it. Doc type note, which is right here, defines a root element of the document named note, which we got there. Element note, oh, it's talking about here. Okay, so element note defines the note element must contain elements to, from, heading, and body, which you can see they're doing that. So if this was called, if they didn't have that, right? If they just had like, this was called something random like Bob, it would give an error. It wouldn't be able to parse it correctly because it doesn't match the DDT file. Element 2 defines a 2 element of type PC data. So it's the element type from also PC data heading, PC data element, and the body PC data. Basically the same exact thing. PC data means parsable character data. So I guess just text is what it's talking about. So how do you define a new element with, exclamation point element? How do you define a root element with doc type? How do you define a new entity with the entity? So this is all pretty straightforward stuff, to sort of general introduction to how XML parsers sort of work. So now let's take a look at XC payload and see how they work. All right, so this first payload is simple. If you read the previous task, you'll understand this payload very easily. So yeah, they have a root element here called replace, entity name feast, and then they have user info first name Falcon, last name ampersand name. So here they have basically it's called an entity in XML, but it's basically just a variable called name, and it's set equal to feast, right? And then when they actually started writing their XML, instead of putting the feast here, they put the variable name. And to put a variable, you have to put ampersand name and then semicolon. So then when this is basically getting interpreted as Falcon and feast, because name is equal to feast here. So this name is essentially variable, and then we're just putting the variable here instead of the actual literal value of feast. And then this is in here, defining an entity called name and assigning a value to feast. And then we use that entity in our code. We can also use XC to read some file from the system by defining an entity and having it use a system keyword. So here we define a variable or an entity called read. And then using the system variable, we were able to get the contents of a file by doing file colon and then / and then the path of the file, which in this case, etc path_bd, which for those who don't know, that's like the in Linux, that's the file that lists all the users and groups on that machine. And then you can see here, they have the element here, and they have the variable read, which they're then using in their code to basically display or print out. Here they're finding an entity name read, but difference is that we're setting it to a value system and the path of the file. If we use this payload, then a website vulnerable at XSC will display the content of the file etc path_bd. In a similar manner, we can use this kind of payload to read other files, but a lot of times you can fail to read files in this manner for the reason, or the reason for failure could be the file you're trying to read. So try the payload mentioned in the description on the website. So I think if we go back here, I got to terminate this guy and start up this machine here. Okay, I've got to give that a minute. I'll go ahead and close these. Let that start up. We'll go back here. All right, we got an IP. Let's go ahead and go to the website. Okay, so this site is not exactly, super realistic. It's basically telling you to give it an XC attack. In most cases, this will be like, they'll ask you to upload an XML file, and then you embed your XFC inside of that file and then upload it and see it works. This is sort of just cutting out the middleman, just so you can like actually practice your XFC, especially if you're just getting started out. So we don't have to like encode it into a file or anything like that. We can just upload it directly to here. So let's go ahead and try some of these payloads on it. So we'll start with this first one, which isn't actually any sort of exploit. It's like literal like XML the way it's supposed to be. So we'll copy this, paste it in there. And then notice here, it printed out Falcon Feast. And if I paste it here again, we can look here. So it's printing out Falcon, and then the variable name, which is going to be Feast, which is why I print out Feast. So pretty straightforward. Now, if we were to put this guy here, which is going to do similar thing, but instead of having the variable feast, it's going to have the variable, or even what I'll do here, I'll just edit this code. Instead of putting feast, right, we'll put system, and then, is it in quotes? Again, I should remember. It is in single quotes. Okay. System, and then file, colon, / / and then / etc pass to UD. And then let's go ahead and then if I did this right, I could have gotten syntax wrong, but if it is right, it should print out Falcon and then the contents of etc pass to BD, which as you can see, it does. I think Falcon is getting cut off somewhere, but it's getting printed somewhere here. But as you can see, we have the contents. This is the contents of etc pass to BD. And if we go to, I think, view page source, we can see it in a much more nicely formatted way, as you can see right here. Boom, just like that. So that works. Awesome. We got that done. So that's sort of just how a very basic XC payload sort of looks like. So now let's see some payloads in action. Let's see what the website will look like. We try to use payload for displaying the name, which we just did. And let's try etc pass to BD. We got that. Try to display your own name using any payload. Okay, so we'll go back here to this paste guy here and make sure that still works. Okay, cool. And then instead of doing read as this system guy, I'm just going to put it as I'm going to put it as John, right? And then it should just display John. And look at that, it works. So that's like non-malicious accuracy. So like if you're like doing like a pen test on a web app, I mean, obviously you want to try to probably read etc pass to BD because it's not going to cause any harm. But if you wanted to be extra safe, you can just try just putting your own like name or stuff like that. But usually you want to try to at least push it a little bit by trying to read any sensitive files, such as the etc pass to BD file. But let's see. So try to spell your name. We did that. See if you can read the etc pass to BD, which we already did. What is the name of the user in etc pass to BD? So let's go back here and give that a go. So again, I'm going to go ahead and do view page source because that's impossible to read. And it's asking for what is the name of the user in etc pass to BD. So there's a lot of users here, obviously, but they're referring to the the non-default user on here, which is going to be at the very, very bottom, and it's called Falcon, or not pollinate, Falcon. So that will be our answer there, Falcon. Where is the Falcon's SSH key located? So this one was an interesting question, and one like that I just sort of made like an educated like assumption on, which is like where like basically all SSH directories are located, which is always going to be in the user's home directory and then .ssh. But if we really wanted to check to make sure, we could try executing a system command. Let me actually Google here, xxe execute command. Let's see if we can do that here. So that's reading files. Okay, here. So it's going to read system and then expect : //. So what we're going to do here is instead of file, we're going to do expect, and then it's going to be expect : // and then whatever the actual thing is. So we're going to do // who am I, just to see if it actually works. Submit it. Okay, so it's possible that this guy is specifically protecting against that just because like this is a lab and we don't want to have to like get a full shell on this. At least I imagine that's what it is. Make sure I actually typed that in right. Oh, I put entity. Did I put that last time? I don't actually remember. Expect : / ID. Okay, let's give that a shot. Okay, that doesn't seem to be working, but let's just to make sure, let's copy this as guys. Okay, yeah, no, so this one isn't working. Okay, so it might be just blocking against the executing shell commands, which is okay. So I just made a very educated assumption that like all Linux users SSH directories is located in the home directory in the .ssh directory, and the actual SSH key is located in it's called ID RSA. But what we can actually do to I don't want that. I want, let's go back here to file contents. Let's go that way. What we can do, just like to check our if we're right or not, is literally just go like file and then do /home/falcon/.ssh/ID_RSA and then do submit button, and then boom, we have the RSA private key of the Falcon user. And so what this means that because they have their private key, their SSH private key, we can SSH into this machine or into any machines that the Falcon server is allowed to SSH into. That's something that's like really big for us. Which I'm guessing that's why they asked us like, all right, where is it located? Because if you can find that, then you can SSH into the machine, and then you have full access to it. What are the first 18 characters of the private key, which we have right here? It's just got to count them all 18. I think it stops at EA7, so it's goes all the way to there, and that's the first 18, I think. And then that's basically it. So that's a good introduction to sort of XXE attacks. Again, like I was saying before, you're going to be hard pressed to find these out in the real world, but it's also a useful one to really know because it's like something that was super popular sort of like in earlier years. And so definitely something that's like a good introduction to understanding more complex types of attacks, such as this one. This is probably one of the most complex ones in the OWASP top 10. And so definitely deserves to be taught about, to learn about, even if it's like not super popular, because whatever the next vulnerability that comes along it might be similar to XXE. And so you already have a sort of background knowledge of how these kind of attacks work, and you can use that to help you with whatever the next vulnerability that comes. So I'll go ahead and close this. Okay, so that was the end of the meeting. Thank you guys for coming. Next week, I'm not sure what I'm going to do yet. I'd like to do remote file inclusion because I know the week before we did local file inclusion. So I'd like to do also remote. The issue is finding a lab that includes remote file inclusion. There aren't any on TryHackMe, so I have to look around. So I'll try to do remote file inclusion, but if not, we might just be finishing up the OWASP top 10 and do the last ones here, which are going to be broken access control, security misconfiguration, and insufficient logging and monitoring. Just sort of round that out. But yeah, if you guys any topic you guys want to learn about, either probably not for this semester because I think we're running out of time, but for in the fall for next semester, you can put in the Google Doc. And then again, if any topics that you guys want to learn about, also put in the Google Doc and then reach out to either me or Claire, or whenever you do reach out to whoever is currently in charge of the red team, and they can probably help you set up some sort of lecture to sort of give to this kind of meeting. But yeah, that was everything. Thank you guys for coming. Thank you guys for listening or watching, and I'll see you guys next week.